So I want to go and do a tour of the brain. Now this is our wonderful brain here. We have two different hemispheres, the left hemisphere and the right hemisphere. And then down the middle here we get this corpus callosum, which connects both the right side and the left side. And in a minute I'm going to go and show you some research and experiments that have been done in schizophrenic patients that sever this corpus callosum. So really, for our brain, we have three different areas of our brain. The hindbrain, which is the oldest part of our brain, we can think of as our brain stem. This bit here, the basic part of our brain, the brain stem. And this is the oldest part of our brain. We then have the midbrain, which is the middle part of our brain. I'm not sure it's on here actually. Which is up in the middle. And then we have what we call the third part of our brain, which is the cortex. And that is to do with our complex processes. So as you get higher within your brain, the processes get far more complex. So we're going to start off looking at this hindbrain, and this is the lowest part of the brain. And is made up of the pons, the medulla, or the medulla oblongata, and the reticular articulation system. So this is the medulla oblongata. This is your pons as you go up higher, and right through the middle, that is not on here, but right through the middle here is what you call your rectal formation, which is very important. Without it, you would be in a coma. Your medulla, we've gone to our pons. Your pons here is important for all sorts of different things with regard to sleeping, waking, and also facial expressions. Okay, so your pons is involved in sleeping, waking, and facial expressions. If we look at your medulla oblongata, which is this bit here, it's all about autonomic functions such as breathing and heart rate. So our hindbrain is all to do with our vital functions. We can then move up to look at our cerebellum. Now our cerebellum is this wonderful collie-shaped flower at the back of our brain here. It is interestingly important for motor movements. When you have had too much alcohol, it is your cerebellum that gets affected because you lose that sense of balance. It plays an important role in cognitive tasks, analysing sensory information with solving problems, and also has some function in understanding words as well. This beautiful shape at the back here we call the cerebellum. We can then move on to the thalamus. Now the thalamus is important because it deals with all of your sensory information. Everything that comes in through your eyes, your ears, your touch goes through your thalamus. Everything but your sense of smell. Smell is the one thing that does not go through your thalamus. And that goes back to the caveman and survival instincts. You need that direct link from your smell. Doesn't go through your thalamus, but instead goes through to the, let's see if I can find it, olfactory bulb here, 2 bits here. That is to do with your sense of smell. And it's all to do with survival. If you're eating food that's rotten, you need to know about it. If there's a fire, you need to know about it. So every part of your senses go through your thalamus apart from this olfactory bulb. Okay, next we're on to the hypothalamus and our pituitary gland. Your hypothalamus, this little thing here, provides a wonderful link between the central nervous system and your endocrine system. You know it's kind of the headmaster of the endocrine system and does a lot of controlling of very autonomic nervous system parts of temperature regulation within your body. It makes you sweat. It makes you shiver. It's the part that contains your biological clock, and it controls your pituitary gland. Now you should all know that your pituitary gland is what makes and secretes the hormones that are important with the long-term regulation within your body. We can then move on to your limbic system. Now your limbic system is very important for emotional regulation. It is involved in arousal, not the sexual kind. It is to do with our emotions and our responses. Now there's some brilliant research looking into serial killers and psychopaths, and those people who are more likely to be a serial killer have smaller amygdalas than the rest of us. And there's a PhD in here for you somewhere. If you get a whole load of babies and measure their amygdalas, you could maybe predict how many of them would go on to be serial killers. It is quite a fascinating concept. We can see it here, yeah, the tiny little bits here within the limbic system. So the limbic system controls all your basic emotions, your fear, your pleasure, your anger. It's all about your drives, your hunger, and caring for offspring. Okay, moving on to the hippocampus. These 2 wonderful shaped bits here are your hippocampus. Some people think they look like seahorses, the shape of seahorses. Now hippocampus is brilliant. It's all about memory. All about your memory. Sometimes when you've been revising really hard and you have sometimes when you've been revising really hard, you get that brain ache and it really hurts and you feel like your head is full of information. There are some people who believe that you can actually get the hippocampus full of information and actually you need to go to sleep in order to process that information. There's also research out there on your hippocampus that says it can grow. You can actually build your hippocampus up. Particularly in England, we have cabbies, taxi drivers that drive black cabs. And they need to remember every road in London. And if you measure their hippocampus before they take their test and after they take their test, you can see that it has physically grown. If we measured your hippocampus before you took your finals and after you took their finals, I wonder if we could see that they had grown. So all about memory and learning. Now, the most important part to do with our higher functioning is the cortex. And we can see that there's a right side and the left side of our cortex. And it is split down the middle by this corpus callosum. Now we know that the right side of our brain controls the left side of our body, and the left side of our brain controls the right side of our body. And the information is transferred between the two through this corpus callosum, which is just placed above our limbic system, but below our cortex. This is all to do with the higher order functioning, our mental abilities. Now, within the cortex, we have lobes of our brain. This is the frontal lobe. We have 4 of them. The frontal lobe, the parietal lobe, the occipital lobe, and our temporal lobe. Now, the frontal lobe is incredibly important. It is the most advanced part of our brain. It's the largest of the lobes. And it's all to do with our abstract thinking, our abstract thoughts. It doesn't stop developing until you're in your mid to late 20s. It's very important. It's about understanding your actions and your consequences, and that doesn't fully form until you have moved on to adulthood. If we look at a particular area within the frontal lobe, we can see that this is called the Broca area. And the Broca was really famous for doing some research within the language part of our brain. And they believe that Broca's area, this tiny little area here in our frontal lobe, if this is damaged, we do not produce language. We don't speak. We can understand it, but we can't produce language. And we'll come back to this when we talk about brain damage in individuals and how we can identify these particular area. But we can call this Broca's area, and Broca aphasia is how we can comprehend language, but we can't use language, we can't produce language if this area of our frontal lobe is damaged. Now we can look at the occipital lobe. The occipital lobe is right at the back of our brain, just above the cerebellum. And this is to do with our eyesight. Think occipital lobe, think opticians. It is all to do with our eyesight. It's our visual information processing centre. So you've got your frontal cortex, which is to do with your higher order functioning, and your occipital lobe, which is to do with your visual information processing. Let's go on to our temporal lobe. Now our temporal lobe is just above our ear, and think ear, think hearing. Okay, your temporal lobe is just above your ear and has a lot to do with your hearing. Now your temporal lobe also has this area called your Wernicke's area, and like your Broca's area, which is to do with pronunciation of language, if you damage the Wernicke's area in your brain, you do not understand the meaning of language. And this was an amazing study that had been done. There's a very particular part of your brain that we call the Wernicke's area, and if you damage it, you don't understand the meaning of language. Okay, the last lobe is your parietal lobe, which is in the middle here. Think parietal lobe P, think perception. It's all about your senses. Okay, all that information coming in about pressure, pain, touch, temperature. Okay, so think parietal lobe, think senses. It's all about perceptual information. So you have two sides to your brain. You have the corpus callosum, which attaches and sends the information to both sides. And then within that, you have four very particular different lobes. The frontal lobe is the biggest lobe to do with the higher order functioning. Your occipital lobe is to do with your vision. Your temporal lobe above your ear to do with your hearing. And your parietal lobe, think perception, is to do with all that perceptual information and sensory information. Okay, let's go on to look at hemispheric specialization. Now, hopefully you haven't got too much longer and you can get going home and have a nice warm cup of tea. So, Dr. Roger Sperry was a neuroscientist and he actually won a Nobel Prize for doing research into this kind of split brain research, doing surgically cutting the corpus callosum. So he did some brilliant research looking into whether people were right-brained or left-brained. Well, actually, although language is predominantly on our left-hand side, and we know that because Barocca is part of our brain on the left-hand side, we know that Wernicke's is on our left-hand side. Language can be on our left-hand side. But on research done with babies who have schizophrenia, who have their corpus callosum severed, we know that they can learn language and they can learn a lot of normal personality traits. And if we look here, there has been some interesting work on intelligence and the ability that eating remains intact. So actually, we can regenerate our brain to use both sides of the right and left hemisphere. But what he did find, that language and some other abilities were still impaired. So this split brain research is actually quite fascinating. And you can see here, with the right visual field and the left visual field. You should know this. The right visual field goes into the left-hand side of our brain, and the left visual field goes into the right-hand side of the brain. And some great research here was shown with a lady who has had their corpus callosum severed. And if you look at the centre of the picture, if you ask the woman to point to the face, she pointed to the one on the left-hand side. And if you asked her to verbalise what she saw, she would verbalise the one on the right-hand side. So this is a great demonstration of this severing of the corpus callosum. Now, I've got a great video with using split brain patients. And we're going to go and have a quick look at brain damage and affective behaviours, just for the last bit. So it's really interesting to study brain damage and the areas of kind of the Wernicke's, which we know is on the left-hand side. In brain damaged individuals, we can see specifically where these lie. Now, this is a very famous case of Phineas Gage, who had a metal rod stuck through his head, but he actually survived. And from this, we've got a lot of data. We've got a of an understanding. So he was a railroad worker, and he was a really nice guy, he was friendly, and he was efficient at his job. But there was an accident, and he got this metal rod stuck through his frontal lobe and went through his left side of his brain. He survived, and he could speak and think he could remember, but there were a couple of changes in his personality. He turned out to be a little bit different. He was foul-mouthed, ill-tempered, and unreliable. And this research was amazing because it was the first time that we could really identify that our personality came from that frontal lobe. That frontal lobe damage, we could see that his personality had changed, and from that we could identify that it was the frontal lobe that was involved in our personality. So while neurology was really in its infancy, this gave us an insight into whereabouts in our brain the different lobes and the jobs that they do. Now, I don't know if any of you here have this propriopagnosia. Does anybody have facial blindness? There must be a few of you in here that do by process of elimination. They just can't see facial features. It is amazing in your brain. Let's have a quick look at facial recognition. People who have face blindness.
Recognizing faces for as long as I can remember. His face may not be familiar, but his books should be. Neurologist Oliver Sacks has written 10 bestsellers about the way the mind works. One, Awakenings, became a movie, and Robin Williams' character is based on Dr. Sacks.
Where are my glasses?
They're on the face.
Oh, thank you.
Now Sacks is revealing his own brain disorder, an inability to recognize faces.
Facial recognition is an amazing achievement.
But for Sacks, every face looks pretty much like every other face. It's called face blindness, or prosopagnosia.
Can you describe what you're seeing, or maybe what you're not seeing? I see all the features, but it doesn't quite add up to a unique image.
For example, look at these famous faces, easily identifiable. Now look again. It's still the same eyes, nose, and mouth, but the face is much harder to recognize. Someone who is face blind sees the features, but can't place the face.
If you can't tell who is who, how do you respond? Sometimes I kiss or embrace strangers, thinking that I know them.
It's so bad that when Sacks wrote a book reminiscing about his favorite uncle, he used a picture of someone else.
When this was published, Uncle Tungsten's children wrote to me indignantly, and they said, "Are you mad? That is not our father, and it looks nothing like our father."
He fixed it in the paperback. Now he is able to recognize people if he has enough clues.
Is there anything familiar about this face to you? I feel it ought to be familiar, and I have a vague sense of familiarity. Whoever it is obviously imminent, very much at ease with poise and pose. I don't know, could it be Reagan? Well, how did you arrive at that? There was a feeling of extreme self-assurance.
Harvard researchers studying this disorder estimate 1 out of 50 people have it.
With regard to face blindness, we can point to a particular area of the brain and say it comes from here.
Right. And you can also stimulate that area, and the person will see faces, will hallucinate faces.
The sufferers include the artist Chuck Close, who gained worldwide renown with his portraits of faces.
We have to prove to the people who we see that we care about them, even though we're not going to recognize their faces.
It's one reason he paints family, like his daughter Maggie and his wife Leslie.
There are millions of us, of my sort, around who require, if not help, some sort of understanding or some sort of tolerance.
And actually, my entire family has face blindness.
By going public, Oliver Sacks hopes face blindness will be accepted, much like dyslexia. A little recognition for those who can't recognize. For CBS News, this is Dr. Sanjay Gupta, New York.
So 1 in 50 people have this face blindness. So you will come across people in your medical practice who will have this unbelievable unrecognition of faces. I really can't believe nobody in this room had actually got it. That's amazing. Okay? So if we look at the application within the medical setting. So you're going to come across people who have epilepsy and surgery and those that just cannot cope with the medication. The seizures are still too much with their epilepsy and they will need to have brain surgery and they'll need to have this corpus callosum separated. And some of you may be aware of the WADA test, which is used to determine whether this is going to be an applicable treatment. It looks at which side of your brain is more dominant, in particular things like language, and whether or not you would be able to cope with the brain functioning afterwards. It's quite an interesting test. So the role of the neuropsychologist is to make use of the brain behaviour knowledge and to administer these tests to anticipate the kinds of behaviour that the patient is going to lose after surgery. So it's a really interesting field if anybody is interested in going into that mental health epilepsy side. Okay, we're going to have a little bit of fun now. Wake you all up. You've been sat there for hours in the freezing cold. We are going to have a little look at some psychological tests. We're in neuropsychology, you can test for memory, you can test for psychomotor speed, and you can also test for what we call executive functioning, which is about our mental control and our self-regulation. Now, with children who have ADHD, or individuals, some of you might have ADHD, it's your executive function, that self-regulation, that is problematic when you're controlling for it. So we can test for all sorts of different neurodegenerative issues or self-regulation, more executive functioning issues. Now we're going to have a look now at the trail-making test, the Wisconsin card sorting test, and the Stroop test. So if you will, have a look at these dots. This is the trail-making test. Can you begin at number 1 and track as quickly as you can to number 13, and then from number 13 it changes, and then it becomes letters. Now the trail-making test is a neuropsychological test of visual attention. And it also looks at task switching because it's looking at the difference between the numbers and the letters. And the test provides information about visual searching speed, about scanning speed, speed of processing, and your mental flexibility as well. It is sensitive to detecting cognitive impairment associated with dementia and also with Alzheimer's. So how did you get on? Was it easy? Not so easy. Okay, if you had Alzheimer's or dementia, if you had ADHD, it might take you far longer than those who have typical brains. So that is the trail-making test. The next test, and this is quite a famous test, the Wisconsin card sorting test. You have lots of different cards and you need to sort them by colour, by shape, and by different type numbers of features that are represented on the cards. This test can be administered to children as young as 6 and as old as 89. And the test relies upon a lot of different functions, cognitive functions, that help us to understand and measure individuals' competencies in abstract reasoning and the ability to change their problem-solving strategies and the needs. So it's all about our visual processing, our attention, and our working memory. And the faster you do it, the better your mental cognitive abilities are. Now, how many of you have heard of the Stroop test? Okay, you're going to have a go. What I would like you to do, you can say it out loud, you could say it to yourself, is can you say the word that you see? Okay, that was easy, yeah? No challenge at all for you bright medical students. The next thing I want you to do is I want you to say the colour that you see. Not the word, the colour. There's a lot of laughter. Okay, so you were quite a lot slower when you had that conflicting attention. Okay, so this is a really good task for understanding our selective attention. And it's harder to read the colour than it is to read the word. And we can look at our reaction times of how fast you are able to say the word. And again, problems related to our executive functioning, like ADHD, Alzheimer's, will have much slower reaction times doing these tasks. So being a neuropsychologist is great. You get to do a lot of fun things with patients. And if you are in the medical side of it, you even get to separate people's brains into two halves. Now, finally, for the last sort of 10 minutes, we're going to look at the gender differences. Are men from Mars and are women from Venus? Now, unfortunately, I cannot get the YouTube link to work, so it's either a good thing or a bad thing, depending on how you look at it. So I apologise for that. It might be up and running later, but at the moment it's been taken off YouTube. So it's no secret that looking at men, looking at women, they look different. They look very different. And the differences between genders are extended beyond what the eye can see. Research reveals major differences in distinguishing between male and female brains when we look at things like processing, chemistry, structure, and activity between the two different gender brains. But of course, there are always exceptions to the rules. Now, there's some lovely research done on reading and reading thrillers, sort of that anxiety and that fear response from when you're reading a book. And you can see here the lobes that are highlighted on the different sides of the brain within males and females. There do appear to be sex differences in the lateralization of language. And this might come down to the fact that men and women's amygdalas, that fear response, the size is different. Possibly because the evolution, we just haven't caught up with the cavemen mentality. We can see that males have more grey matter for information processing, and females have more white matter, which is about connecting those units together, binding that grey matter together. In general, men have approximately 6.5 times more grey matter, and women have nearly 10 times the amount of white matter. So structurally, they can be quite different. However, we need to look at this critically. Research suggests that there are many sort of stereotype differences between males and females which are not substantiated with research. Women are not more talkative than men. If anybody's ever met my brother, my goodness, he could talk the hind legs off a donkey. There are no differences in the way that males and females talk. There are also no real differences between the mathematical skills between the two genders. Boys are not better at maths than females. And actually, their tests of IQ indicate sort of very similar test scores as well. So really, we need to think about the differences and the similarities of the brain, are different with structure, but IQ and everything else can be thought of as just stereotypical differences. So sex differences in the brain could actually be the result rather than the cause of these behavioural differences. Okay, so I'm going to go and talk about your reflective journal in a minute, so stay put if you want to hear about your reflective journals, otherwise you can go after this. So upon completion of this lecture today, you should know about the nervous system, you should know about the central nervous system and the peripheral nervous system. You should know about how neurons communicate both electrically and chemically. You should know about the central nervous system controls immediate responses to the environment, where the endocrine system and the hormones are all about the long-term changes within your body. You should know about mapping of the brain to do with EEGs, MRIs and PETs. You should know about the hemispheric specialization and the differences between the left and the right side of the brain. You should know about the wonderful research that's been done in the brain damage and how this can cause brain plasticity and changes in behaviour. And the gender differences of the brain could be observed in structural differences and also activation differences within different sides of language. Right. Well done, you've survived another lecture. Give yourselves a round of applause. You're still here and you haven't frozen into snowmen.